Hello all, my name is Sushma from Sri Venkateshwara College of Engineering and Technology Chittoor, and today I will represent the presentation on microwave oven stimulation as a part of my internship project at emertxe. First, we see the table of contents which we had learned during the internship. The first is microwave oven. Then we have learned about introduction to C programming. Then we will see the requirements of project. Then what is an embedded system, components of embedded system, microcontroller and microprocessor, PIC lab stimulator, project peripherals, CLC, display, tactile switch, matrix keypad, interrupts and timers, and at last I will show the project implementation and the demo. So first we will see what is microwave oven. A microwave oven, or simply microwave, is an electric oven that heats and cooks food by exposing it to electromagnetic radiation in the microwave frequency range. There are many different modes in a microwave oven. Some of them are micro mode, grill mode, convection mode, and the last one is start mode. The first one is micro mode. This mode uses a maximum power of 200 volts. The maximum time that can be set is 60 minutes. This mode is used for traditional cooking. The second one is grill mode. This mode allows to use two microwaves heating element for cooking. User can set time for cooking the food. The third one is convection mode. In this mode, user can set the oven to preheat by selecting a particular temperature. The preheating is done for 3 minutes, that is 180 seconds. And at last, start mode. It is a standard mode used for cooking and heating in a microwave oven. Then in this internship, we had studied what are the basics in C programming, and which we had studied about functions, variables, strings, operators and operations, conditional statements, loops, storage classes, and last, arrays and pointers. Now we will see the project requirements which we need to complete the project. We need the basic knowledge of embedded C programming, MPLAB-X IDE, XCE compiler, PIC lab, which consists of PIC 165 F877A, 16x4 CLCD, tactile switch, matrix keypad, and timers. Next, we will see what is an embedded system. An embedded system is a specialized computer system designed to perform a specific task or function within a larger system or product. Or simply we can say any combination of hardware or software intended to do a specific task is known as embedded system. We had studied about various components of an embedded system such as power supply, microcontroller, memory, timer or counter, communication ports, input or output port. Then we have studied the flowchart representation of embedded system, which we can see here, the flowchart representation of embedded system, how it looked like. Next, types of embedded systems. Standard alone system, example semi-automatic washing machine. Second one, real-time system, example car airbag system. And third one is network system, example home security system. And last one is mobile system, example cell phone. How to choose embedded system? So for choosing embedded system, the embedded system should be reliability, cost effectiveness. It has low power consumption. It should have effective usage of power and effective usage of memory. Now we will see what is microcontroller. A microcontroller is a compact integrated circuit that contains a processor, memory, input or output peripherals, and often additional components like timers, communication interfaces, and analog to digital converters. Microcontrollers are designed for embedded systems and are used to control various devices and systems, providing intelligence and functionality to those systems. The design normally has restrictions on its memory size, input or output capabilities, peripheral functions. So now we will see how microprocessor is different from a microcontroller. A microprocessor is the central processing unit of a general purpose computer. It is designed to execute a wide range of instructions and is typically found in personal computers, servers, and workstations. It primarily consists of the CPU and does not include extensive integrated memory, input, or other peripherals. These additional components are typically added separately on a computer motherboard. Now we will see about PIC Lab Stimulator. PIC microcontrollers are a family of microcontrollers developed by microchip technology, and there are various stimulation tools available to help you stimulate and test PIC microcontroller projects without the need for physical hardware. MPLabX IDE is an integrated development environment that supports microchips, PIC microcontrollers, and provides stimulation capabilities. This is all about PIC stimulator. Now we will see the current sinking and current sourcing circuit. The current sourcing circuit, which is on the left side, we can see here the current flows out of the device and goes through the load. In current sinking circuit, the current flows into the microcontroller device through the load. This is all about current sinking and current sourcing. Now we'll see about CLCD display. Means character liquid crystal display. In PIC Lab Stimulator, there are two types of displays. One is 16x2 display and 16x4 display. We will use the 16x4 display for this project. There are two types of communication modes. One is 4-bit and another one is 8-bit mode. Here we use 8-bit mode. Then we have used tactile switch in this project. It is a electromechanical device used to start or stop current flow along with a circuit. Next, we use a matrix keypad. A matrix keypad consists of an arrangement of switches connected in matrix format in rows and columns. Keypad is an analog switching device which is generally available in matrix structure. It is used in many embedded systems application for allowing the user to perform a necessary task. In this figure here, we will see how the matrix keypad looks like. Next, interrupts. Interrupts are the fundamental concept in computer systems and microcontroller or microprocessor architectures. They are mechanisms used to temporarily stop the normal execution of a program or process in response to an event, signal, or condition that requires immediate attention. PIC 16F877A has 15 types of interrupt sources. One is ISR, which is interrupt service routine, or also known as interrupt handler or interrupt subroutine, is a specific section of code or subroutine that is executed in response to an interrupt event. And the last one is timers. Timers are essential peripheral modules in PIC microcontrollers that provides precise timing and counting capabilities. They are widely used in embedded systems to perform tasks such as generating precise time delays, measuring time intervals, and controlling internal devices. PIC microcontrollers from microchip technology often feature multiple timers with various configurations and functions. Example, timer 0. This is basic 8-bit timer with limited functionality. It can be used for simple timing and delay generation. This is all about which we had learnt in this internship. Now I will show you the project implementation and the demo. So now we will open MPX IDE compiler. Here we can see the program main.c, which was like this. And next we will see main.h. Main.h file is like this. And next clcd.c. Next we will see clcd.h file and matrix keypad. Next timer.c. And this was all about the code which we have done. Now I will show the stimulation of the code of microwave oven in PICSIM lab stimulator. Here first we need to select reload, and then here we can see the 4 modes. They are micro, grill, convection and starter. These are mainly the 4 modes of microwave oven. If we want to keep microwave oven on, we need to press 1. Now I will press the key 1. We can see the micro mode has been started and it uses a power 900 ohms. Now we can here set the time. To set time, just press the keys below. Firstly, I will keep the time of 30 seconds. So we press 30, and now to start it, press hash to enter, and to erase we can also press start to clear. Now I am pressing hash to enter. We can see the fan has been started and the microwave oven has started to cook or heat. Now as the time to pass, we can press 5 to pass. The microwave oven has been passed. To start, we will press 4. We can see here again it is started, and to stop we will press the key 6. By pressing key 6 we have stopped and the original screen has been displayed, that is the starting one screen has displayed. Now we will see the second mode, that is grill mode. The grill mode has been started by pressing second key. Here we can set the time 1 minute 30 seconds, or so that to set the time I will press 30, and for 1 I will press 01. So now the time has been started, and press hash to enter. So we can see the oven has started again, and simply for to pass select the key 5 to pass, and again To start, we can select 4, and to stop, select the key 6. Again, we back it to the screen display like before. Now we will see the third mode, that is convection mode. Convection mode is used to preheat the microwave oven. The convection mode has been started by pressing third key. Here in convection mode, we need to preheat the oven. So for that we have to enter the temperature to preheat. So let us enter 45 degrees temperature from the keyboard and hash to enter. And now we can see the preheating is done in 3 minutes, that is 180 seconds. And now we can see the time, it is taking 180 seconds to preheat. We can also press the reset key to go back to reset the microwave oven, and we will get the same screen as displayed original. Now I will tell you about the fourth mode, that is start mode. By pressing the start mode, the microwave oven has started and it heats for the time 30 seconds, and after 30 seconds it again stops. It stops, we can see the time up screen and the original screen is back again. So this was all about the project implementation and the project demo. And at last, I want to thank emertxe for giving me this great opportunity and providing me great learning. Thank you.